Alright, we'll start with the next numerical. Okay, a uniform a uniform meter ruler is pivoted at its midpoint. So suppose you take a meter ruler, okay, a 1 meter length, that is 100 centimeter. Okay, it is pivoted in the middle, that means at 50 centimeters. A weight of 50 GF or 50 gram force is suspended at one end of it. So at one end you put 50 gram force or 50 gram weight. Okay, where should you where should a weight of 100 GF be suspended? Okay, as soon as you put this weight, since this ruler is already balanced, as soon as you put this weight on it, what will happen? The ruler will tilt towards, or it will move in an anti-clockwise direction. Okay, the ruler will move in an anti-clockwise direction. So what they are saying is that we should put, where should we put this 100 gram force, okay, to be suspended to keep the ruler horizontal. So once it starts tilting, we have to put this weight. Okay, you have to put, where we have to put this weight, that we have to decide. Alright. Now, so what has been given to us? So first we'll write what has been given to us. So there is a weight 1. So first we'll write on the left hand side, we'll consider as weight 1 is 50 gram force. Okay, and what is the distance? What is this distance? It is kept at, so this distance is 50 centimeters. Okay, because the ruler is pivoted in the middle. So length L1 is 50 centimeter. We have to find this length. Where we'll be keeping that length, we have to find out, and the weight has been given to us. So W2 is equal to 100 gram force. Alright. Now, according to the principle of moment, okay, sum of anti-clockwise moment is equal to sum of clockwise moment. Okay, so sum of anti-clockwise moment, so this, because of this weight over here, it will perform an anti-clockwise moment. Because of this weight, it will perform a clockwise moment. Now according to the principle of moment, a body will be in equilibrium, or it will be balanced, or the ruler will be horizontal, okay, if both this are equal, if sum of the anti-clockwise is equal to sum at the clockwise. All right, so just write it in a formula, that is W1 is equal to L1 is equal to W2 into L2. So W will substitute the values. So 50 gram force into length is how much? 50 centimeter is equal to 100 gram force into L2. So L2 is 1, we have to find out. So we'll move this on the other side. It will become 50 gram force into 50 centimeter upon 100 gram force will equal to L2. 0 0 cancel, 0 0 cancel, gram force cancel. 5 5s are 25. So L2 is equal to 25 centimeters. Okay, so where you'll be keeping this, it will be somewhere over here at 25 centimeter from the center. Okay, all right, we'll move to the next one. Okay, a uniform ruler balanced horizontally on a knife edge, okay, placed at 58 centimeter mark, when a weight of 20 gram force is suspended from one end. One, draw the diagram of the arrangement, and the second is what is the weight of the ruler. Okay, the first thing, the entire mass of the ruler is concentrated at the center of it. Okay, that means at this point, that is at 50 centimeters. So at 50 centimeters, the entire mass of the ruler is concentrated. Okay, if we move, okay, this knife edge or this fulcrum anywhere, what will happen is this ruler will start tilting. Okay, it will move in an anti-clockwise because of this weight. Okay, because this weight is, the mass of the ruler is concentrated over here, it will go downwards. Okay, hence because of this, the ruler will move in an anti-clockwise direction. Okay, now a uniform ruler balanced horizontally on a knife edge placed at 58. So now they are saying that it has already been placed at 58. That is at this point. Suppose this is 58 centimeters mark. Okay. So it will go in an anti-clockwise direction. Now they have given us a weight of 20 gram force is suspended at one end. So on the other end they are saying that they have suspended 20 gram force. That means this at this distance at other end. We have to draw a diagram of this arrangement. So this will be a diagram that we need to draw. And the other thing is, what is the weight of the ruler? Okay, again we have to find out what is the weight of the ruler. Now when they have suspended this, so this will be W1. Okay, this is W1 and this length. Okay, this will be L1. This is your W2 and this length will be your L2. Okay, so we have to find W1. If we find W1, because it is the center of mass, it will give us the weight of the ruler. Alright, so again the same thing, anti-clockwise moment and the clockwise moment. So according to the principle of moment, sum of the anti-clockwise moment is equal to sum of the clockwise moment. So W1 into L1 is equal to W2 into L2. Now here the anti-clockwise moment is because of the mass of the ruler, so we don't know. So what we have to find out, we don't know what is W1. We have to find W1. We know what is W2. Okay, W2 is 20 gram force. We know what is L1. Now what is L1 over here? L1 is this from the center. Okay, from 50 to 58. That is 58 minus 50. That will give us 8 centimeters. And what is L2? L2 is from 58 till this will be 100. If this is 50, so this will go till 100. So 100 minus 58, that will give us 42 centimeters. Alright, so this distance would be 42. So weight 1, we don't know, so weight 1 into L1 is 8 centimeters is equal to 20 GF into 42 centimeters. Now again weight 1 we want, weight 1 is equal to 20 GF into 42 centimeter upon 8 centimeter. Centimeter cancel. Okay, 4 2s are 4 5s are, okay, 2 1s are, okay, 2 2s are and 2 1s are, 21. So this will give us W1 is equal to 5, okay, GF into 21. So 25 is 100 and 5 ones is 5, so it will be 105 gram force. So W1 is equal to 100 and so the weight of the ruler is 105 gram force. Alright, okay, we'll continue the third one, next numerical. Okay. Now all the numericals are of same type. Okay, draw a diagram, show a uniform bar supported at the middle. Okay, so there is a uniform bar, consider a scale. Okay, it is supported in the middle, that is pivoted in the middle. A weight of 40 GF is placed at a distance of 40 centimeters. So at a distance, so this will be 50 centimeters at 40 centimeters from this distance. Okay, on the left hand side of O, so this is suppose point O, that is at 50. How can you balance the bar with a weight of 80 GF? So they are saying that if you have 80 GF, okay, how you will balance it, or exactly where you will keep this, okay, so that it is balanced. Now again the same thing. So what has been given to us, so we can jot down what has been given to us. Okay, so W1, that is the anti-clockwise torque, is produced because of W1, that is 40 GF. And what is the distance? L1 is given as 40 centimeters. Okay, what is W2? W2 is 80 GF and L2 is what we have to find out. Now again you have to mention this is very important. According to the principle of moment, sum of anti-clockwise moment is equal to sum of clockwise moment, or you can write it as W1 into L1 is equal to W2 into L2. So W1 is 40 GF into L1, that is again 40 centimeters, is equal to 80 GF into L2. So GF will be sending over here, so 40 GF into 40 centimeter upon 80 GF is equal to L2. GF cancel, 0 0 cancel, or 41s are 42s are 80, 2 1s are 2 20s are. So what is remaining? 20 centimeters. Okay, so you can say that L2 is equal to 20 centimeters. So where you will be keeping this L2 weight, it will be at somewhere over here. Okay, that will be at a distance of 20 centimeter, and in that case the scale will become balanced, right? Okay, we'll do this also. Figure 1.33 shows a uniform meter ruler placed on a fulcrum at its point at a midpoint O and has a weight of 40 GF at 10 centimeter mark. Okay, 10 centimeter mark. So there's a mark over here that is 10 centimeter, and a weight of 20 GF at 90 centimeter mark. Okay, at 90 centimeter mark there's 20 GF. Okay, is the meter ruler in equilibrium? So they are asking whether it is balanced. Okay, if this is the scenario, so let us check. So what has been given to us? So given is W1 is equal to 40 GF, L1 is equal to, now this distance is how much? So it is at 10 mark, 10 to 50, so 50 minus 10, that will be 40 centimeters. Okay, second is it is placed at 90, so 90 minus 50, this will be also 40 centimeter. Okay, so W2 is equal to, how much it is, 20 GF, and L2 is equal to 40 centimeter. Now again same thing will apply, and we'll see whether if they are equal, in that case it will be balanced. So according to principle of moment, the sum of anti-clockwise moment, so whatever the anti-clockwise moment that is produced by this, okay, if it is equal to the clockwise moment because of this weight and this length, or because of this weight and this length, if they are equal, in that case we'll say that they are balanced. If they are not equal, in that case we'll say that first one, it is not balanced, or it is not in equilibrium. So let us check. Okay, so first we'll put this W1. So W1 is what? 40 GF into 40 centimeter is equal to 20 GF into 40 centimeter. Alright, so we'll just multiply on this side and we'll see how much is the torque that is produced over here. So 0 0 4 4s are 16, so 1600 GF centimeter, and over here it will be 0 0 and 4 2s are 800 gram force centimeter. So of course 1600 is more than 800, so this is not equal. So the first part is the meter ruler in equilibrium? So the answer would be no, it is not in equilibrium. Okay, it is okay. Second part is, if it is not in equilibrium, then in which direction it is moving? Okay, oops, it is not in equilibrium. Okay, if it is not in equilibrium, how will the ruler turn? Okay, so the second part of the answer would be, so 1600 is an anti-clockwise moment. Okay, so W1 and W2, this moment is anti-clockwise, so the ruler will move in an anti-clockwise direction. So you will write it, it will move in an anti-clockwise direction. Okay, now third part First part. This is the second part. Okay, all right. So again, the second part. How can the ruler be brought to equilibrium by using an additional weight of 40 GF? So they are giving us an additional weight. Say an additional weight we have to put. So this weight, where we'll put this weight so that it becomes balanced. Now, what is happening? It is moving in anti-clockwise direction. We have to apply some force on the clockwise direction. Okay, and they have given us weight. Okay, so that it becomes balanced. So what will be the formula now? So it will become, so W1 into L1, that this is for the, so the formula is same, the sum of the anti-clockwise moment. See, sum, so whatever the total on the anti-clockwise moment is equal to sum of clockwise moment. So whatever the total moment produced by these two, you have to add it. So this will be W1 into L1 will equal to W2 into L2 plus, okay, because sum, so we'll plus it into, say for example this is W3 into L3. So this length where we'll be keeping, so L3 is 1 that we have to find out. Now W1 into L1 we have already done it, it is 1600. So 1600 GFC, whatever. This is, we have already done over here, it is 800. It is plus W3, we know how much is W3, they have mentioned it as 40 GF. So they have given a new weight of 40 gram force into length, we have to find out length 3 where we have to keep it. So here it is a plus sign, so this will go on this side, it will minus. So 1600 minus 800 GF, it will become 800 GF, okay, is equal to, so this also will take on the other side. Now this is multiplying over here, so it will divide, so this will come 40 GF, which will be centimeter, okay, and L3. So L3 become this. GF cancel, 0 0 cancel, 4 1s are, 4 2s are, so 20 centimeter. Therefore L3 is equal to 20 centimeter. So once we keep this at 20 centimeter mark over here, say suppose this is 20 centimeter from the fulcrum, this ruler or this will be balanced. Okay, it will get balanced at 20 centimeter mark. That means the sum of anti-clockwise moment that was generated because of this will now be equal and ruler will be balanced. Alright. I hope you understood. Thank you so much. Bye.